Alright, how's it going, guys? I'm going to go ahead and very quickly go through the sine wave test review that I gave you. So that's what this is. Let me see if I can write on here. There we are. Sine waves test review. I'm going to copy the problems from your test review onto here. So this is number 1. I'm going to go ahead and graph. This is f of x is equal to 3 sine of 1/2 x minus pi plus 1. So I'm going to try to draw on this. So I'm just going to go straight down, straight across. We're going to put a grid here. Go a bit higher. Okay, so the first thing we're going to do is take into account your vertical shift. So usually the graph is centered on the x-axis, but we're going to move it up by 1. So the center will be now be at 1 here. Okay, and then what we're going to do actually from there is we're going to look at this 3, and that's going to say, okay, 3 is going to tell us our amplitude. We're going to go, this is the center line now, so we're going to go up 3 units from there, from that line we just put down for the center. And we're going to go 3 down from the center here. So we're going to go 1, 2, 3 down. Okay, so this sine wave is just going to go between this bottom portion and this top portion, with this being the center, which is what we discussed in class. So let's go ahead and figure out the period of the graph. So the period is going to be given as 2 pi divided by the absolute value of b. B is the number in front of x, so it's 1/2. Okay, so basically what I'm saying is that 2 pi over 1/2 is the period, and this is going to equal 4 pi. So once you get 4 pi as your period, you're going to go ahead and mark it off on your graph. So you go ahead and put 4 pi down somewhere, and then you're going to quarter it, cut it into fourths. So 1/2 of 4 pi is 2 pi, 1/2 of 2 pi is pi, and 1/2 in between 2 pi and 4 pi, of course, is 3 pi. All right. And what we're going to do now is use a unit circle to figure out some points. So imagine a unit circle here, and I know the quadrantal angles on the axes here, here, and here. All right, so if I have a point right here on a unit circle, if I imagine there being a unit circle around here, this coordinate would be 0, 1. And this angle, this quarter circle here, is the angle pi over 2. All right, so it stands to reason, because sine is a y value, that I can say sine of pi over 2 is in fact equal to 1. Now what I want out of this, before I start graphing, here's the idea, is I want to take a look at this sine function in my equation here, and I want this entire sine function to equal 1, just like this one did right here. Okay. The only way I can make this happen is that the sine of pi over 2 is 1. So this whole thing that I have here has to be the same thing as pi over 2. So I'm going to actually have to make an equation here and find it. Okay, what value of x can I plug in here that make this whole thing pi over 2? All right, so this is going to equal pi over 2. And then we solve this equation for x. So we add pi to both sides. And these are going to cross out. All right, we notice here that we don't have a common denominator when we're adding these, so I'm going to go ahead and put this 2 on top and 2 on bottom. So pi is the same thing as 2 pi over 2. So if I have 1 pi over 2 and I add 2 pi over 2, that gives me a total of 3 pi over 2. And now that's going to equal what we have here, which is 1/2 x. Okay, so let's move down a little bit. Let's multiply both sides of this equation by 2. Okay, when I do this, this 2 and this 2 will cancel, and this 2 and this 2 will cancel. So now 1 times x is x, which is equal to now 3 pi. This is a point we know. And if I remember this unit circle, I set it equal to pi over 2, this equation, because I'm looking for this point, 1, which will give you the largest possible sine value, which means I should be at the top of my graph, whatever this x value is, which is now we know is 3 pi. So at 3 pi, I'm going to come all the way up to the top of my graph, and let's do this in blue, I think, which is right here. Okay, at 3 pi. All right. So I can now say then that the period is 4 pi. So if I go ahead and mark off some of these other points here, if I go back this way like negative pi, go back a little further at negative 2 pi, okay, I know that the period is 4 pi. So from this point, if I go 4 pi in the right direction or 4 pi in the left direction, I'll end up at the top of the graph again. So let's go over 1, 2, 3, 4 pi, which means it puts me right here back at the top again. So I have a top point and a top point, and right in the middle, right in between them. Okay, remember there's 1, 2, 3 spaces, 3, and 4 spaces here. So half of that will be 1, 2 spaces. Right here in the middle, I'm going to be down at the bottom of my graph, which is right here. So in between the two tops is the middle. In between the, is the bottom. So in between the two tops is the bottom. So in between the bottom and the top here is a middle point at 2 pi, which is right here. And in between the bottom and the top here is a middle point at 0. So what I can see here is a pattern emerging on my graph if I keep the pattern going. So what I have is this sort of thing going on here. My graph, okay? So that's kind of what your sine wave will look like, and that's kind of what I expect you to see, okay? So that's basically how you graph a sine wave freehand, okay? And that's what we're going to be doing, continue to do here. So let's go a little further, and let's see if I can actually create a new page. Yeah, it's a good one. All right. Okay, so number 2. All right, f of x is equal to 2 sine of 2x plus pi over 2 minus 1. Okay, so let's graphity graph this, put some grid lines down, and let's go from there. So take into account your vertical shift, this minus 1. Usually, again, we'll center the graph at the x-axis, but now we're going to go down 1, so we're going to center it here at minus 1, which is right here, okay? And I'm going to go from there 2 down, so 1, 2 down. I'm also going to go 2 up, so I go 1, 2 up, which is right here. That's going to give me my amplitude right here. So we'll go 2 up, 2 down from that. This is really not drawn to scale, but that's okay. And I'm going to go ahead and find my period. My period for this sine function is 2 pi over the absolute value of b. And b is, of course, this number here in front of x. So it's basically 2 pi over 2, which is pi. This is the period right here, okay? So I'm going to mark the period on my graph. I say, okay, that's pi. And then I'm going to quarter it. So half of pi is pi over 2, and half of pi over 2 is pi over 4, and in between here is 3 pi over 4. Okay, so now the goal here is to find some graphs here. So I'm going to get my unit circle here. I have a point, top and bottom, and this coordinate here is 0, 1, and this angle here is pi over 2. So I can infer from this that the sine of pi over 2 is this y value right here, which is 1. The idea now, again, is to get this sine in my equation also equal to 1, which means whatever's inside of here must equal pi over 2. So now I'm going to say 2x plus pi over 2 is equal to pi over 2. I will solve this equation for x. So if I subtract pi over 2 from both sides, 2x equals 0, and x equals 0. This x value will give me the sine value of 1 if I plug it into this equation, which gives me the top of the graph, at the very top of the unit circle. So at x equals 0 right here, which is again right here, I'm going to be at the top of my graph. So let's change color. Let's go to blue. I'm at the top of my graph right here, okay? I know that the period is pi, so if I go pi in either direction, 1, 2, 3, 4 to pi, I'm at the top of the graph again. If I go right in the middle between the two tops, I'll get a bottom. So right in here, at pi over 2, I'm at the bottom, right in the middle. In between the top and the bottom is a center point, and in between the top and bottom is another center point. And what I end up getting is a pattern emerging on my graph if I choose to continue drawing it. So let's do this. Okay, it's kind of what your sine wave looks like, and that's pretty much a rough sketch. That's kind of what I want you to do. It's kind of what I'm looking for. So let's hop down to number 3, and we'll keep going. So number 3. Okay. So let's go ahead and put this grid line down. Get some points marked off. Okay. Let's find the period of the graph, which is 2 pi over this. Well, we need to distribute this 1/2 first, so we're going to distribute that. Hippity hoppity, distributive property, 1/2 x is half x, and 1/2 times this will be negative pi. So this is what I'm really looking at. My b value is this, and that's what I'm going to put underneath this quotient here. So my period will be 4 pi when I figure that out. I'm going to go ahead and mark off the period. So 4 pi, half of that is 2 pi. In between here is pi. Remember, cut it into quarters, so this will of course be 3 pi. Okay, so let's actually do some analysis here. I see there is no vertical shift, so this thing is going to be centered right here at the x-axis. This -2 tells me to go up 2, and it goes down 2 from the center as well. So these are my kind of guidelines for drawing. Okay, yeah, let's keep the black here. We're going to go ahead and look at this unit circle. Again, at this top here, this angle is what? Is pi over 2. So we know this coordinate is 0, 1, and then of course that the sine of pi over 2 is 1. I want this to also equal 1. So I will make the inside of this right here be the same thing as pi over 2. So we'll make an equation out of it. So we'll say 1/2 x minus pi is equal to pi over 2. Now we solve it. 1/2 x is equal to pi over 2 plus pi. I have a denominator of 2, so if I put a 2 on top, I can put a 2 on bottom, make this happen. And then I can say, okay, 1 pi over 2 plus 2 pi over 2 is now a total of 3 pi over 2. And that's equal to 1/2 x. Multiply both sides by 2, and x will equal 3 pi. Now that's the top of my graph here, so I'm thinking, okay, that's where the top is, at 3 pi is going to be a top part of my graph. But this is not correct for this particular case. Something you need to be very well aware of is this is a negative sign, which means my ordinary graph will be flipped entirely upside down. So what I think really is a top point is actually a bottom point for this particular graph. So it's not at the top now, it's actually right here at the bottom of my graph. Okay, so let's use 4 pi as my guide. Okay, if I keep going this way. So I say, okay, after a period I go 1, 2, 3, 4. I'll be down at the bottom again. That's pretty much how it works. In between these two bottom points is a coordinate, pi, so that's going to be where the top is, which is be about right here. And then, of course, in between here and here is the center. In between here and here is the center. And then you get a graph that looks something like this when you draw it. And so on and so forth. That's not, that red line is not supposed to be there. I don't know what's happening, but that's this green graph right there, and that's that. So let's keep moving. I think we're almost halfway done, I think. All right, so let's do number 4. Let's go back to this, number 4. Okay, this is f of x is equal to 1 minus sine of x plus pi over 2. And we have this. Draw it out. Do just a quick couple of hash marks. And then we'll start going with this. This 1 that's sitting here by itself is my vertical shift. I could have easily just said add 1 over here and cross this out. It doesn't matter what side it's on, but this is the vertical shift. So instead of being at center on the x-axis, we're going to be centered here at positive 1. Okay, I can see here in front of the sign there is a negative, or a negative 1 if you want to call it that. So I'm going to go up 1 from the center and down 1 from the center, so it'll be right on the x-axis. Okay, let's find the period out of this. The period is 2 pi over b, which is 2 pi over this 1 right here. So it's just going to be 2 pi over 1. So let's go ahead and mark that off. Let's go ahead and say, okay, this is 2 pi, half of that is pi, half of that is pi over 2, and in between here and here is 3 pi over 2. Okay, so let's use the unit circle. At the top here, I know this angle is, of course, pi over 2, and this coordinate right here is 0, 1. I'm focused on the y, the y coordinate, which is the sine. So it's going to be sine of pi over 2 is going to equal 1. Okay, so I want that here. I want this to also equal 1, which means the inside of this has to equal what? Pi over 2. Well, I can see pretty obviously that this x has to be a 0, because 0 plus pi over 2 will give me the pi over 2 I want. So I'm going to tell you x equals 0 at what I usually will consider the top of my graph, at the top. Again, this is not the case because there's a negative in front of the sign. So what looks like it should be the top right here of the graph is actually the bottom, because this negative, of course, is flipping the graph upside down. So at 0, which is right here, it's going to be at the bottom. So it's actually on the origin. There's a point there. Okay, that's the bottom of the graph. I see that the period is 2 pi. So if I go 2 pi in either direction, like this way, I'm going to hit the bottom again. If I go 2 pi in the other direction, I'll hit bottom of again. In between 0 and 2 pi is pi, and that's where I'm going to hit the top, which means I'm going to hit middle at pi over 2, which is right in between the bottom and the top, and I'm going to hit middle at 3 pi over 2, in between the top and the bottom. So I'm going to get a graph that kind of looks like this as I keep drawing it. Okay, so let's go this way with it. Say this way, this way, this way, this way, and so forth. Something like that, right? It's going to kind of go like that as we go. Okay, so that's what that graph looks like. And we'll go on to the next one. Okay, this is number 5. This test question, this review question, I will not put on your test because you really need a calculator to figure this out because of this little pi x business that I put inside your sine function. So let's take a look at it anyway, just for the sake of argument, to give you an idea what's going to happen here. And let's graph. Okay. Alright, so I'm going to put my guidelines down. I can see this is a vertical shift, -1, so that's my new center. 3 is telling me to go 3 up, 2, 3. That's the number in front of sine. And I go 3 down, 1, 2. Let's go down 3 to here. And now let's graph. So let's get the unit circle going. Again, I say at the top here, this is pi over 2. This will give me the sine value of 1. Okay, so I need this to equal pi over 2. This is the tricky part. Pi x minus 2 equals pi over 2. I'm going to go ahead and multiply everything by 2 to get rid of this fraction. So 2 times, let's multiply both sides, in other words, by 2. Multiply this by 2, and multiply this by 2. 2 times pi over 2, these 2's will cancel. So you just have pi on this side. Distribute this 2, so we got 2 pi x, and then 2 times negative 2, which is negative 4. That means that 2 pi x is equal to pi plus 4. And then I'll divide both sides, of course, by 2 pi to get rid of this. So I can see here that x is equal to this. There's no way of telling really what that is. What is pi plus 4 divided by 2 pi? Well, I put that in a calculator, and I believe what I got was x is equal to 1.137 or thereabouts. So the reason I'm worried about that is because this pi right here is causing it. If you figured out the period, which is what we should have done first, technically, before we did all that work, was that the period is 2 pi divided by this pi, which means these pi's cancel, so the period is 2. So as I mark off the period at 2, the middle part is 1, halfway there is half, and here will be 3 halves. My first point on my graph, which I say is at the top, right here, at the top of the graph, will be at 1.137, which is a little more than 1, because 3 halves is 1.5. So if I go a little further than 1, I'm about at the top right here, pretty much. And of course, the period is 2, so if I go over 2, remember 2 is a space of 1, 2, 3, 4 spaces. So if I go 1, 2, 3, 4 spaces, I'm back at the top again, okay? Which means in between here and here, I'm at the bottom, which is a little past the y-axis at about right here. And then here this is going to be a little bigger than 1/2, and here it's going to be a little bigger than negative 1/2, which is right here. So what I end up getting is a graph that looks something like this. Oops. Let's go through that point. Yeah, it's not great drawing, but there we go. But the tricky part, of course, is finding this x value. You cannot really be expected to calculate that x value without a calculator. So this test question is not going to appear. Okay, not going to appear on the test. So we're going to go ahead and move on to number 6. This was like a bonus for you, I think, on your review, I guess. And you might get a cosine bonus question on the test. I'm not sure yet. I haven't decided, so we'll see. This is -2 cosine of 1/2 x plus pi over 2, and that's -1. So let's go ahead and graph this final one. The only thing different about this one is you notice this is a cosine, so that's something to take note of. And then we draw. My guidelines start at -1. That's the new center, which is down here at -1. My amplitude is 2, so I'm going to go up 1, 2 from there. And down 2 from here, so 1, 2. And let's graph. Okay, so let's go ahead and figure out the period first. 2 pi over absolute value of b. b in this case is 1/2. So this is 2 pi over half, which is now 4 pi. That's your period, so you should write it somewhere, quarter it, and here will be 3 pi. Okay, and let us get going with the graph. Keep in mind, again, I usually have been picking this point for sine because I know that the sine of pi over 2 is 1, but that's for a y value, mind you, okay? But I don't care about this y value. I'm actually only concerned about x values because we're dealing with cosine, which is an x value. So where does cosine have equal 1? It's right here, actually, at 1, 0. Cosine equals 1 when the angle itself is nothing. So I actually want to set this here equal to 0, so it gives me the high point that I want, which is 1. Okay, so say, okay, 1/2 x plus pi over 2, I want it to equal 0. That means that 1/2 x, let's scroll down a little bit, is equal to negative pi over 2. Multiply both sides by 2, x is equal to negative pi, which is easy enough to draw because we'll just go in pi in this direction. This is negative pi. So I say, okay, that must be a maximum point because that's where cosine is 1. But that's not true again, because again, in front of cosine we have a what? We have a negative, which means that this is not a maximum, it's actually a minimum point. So let's put that on my grid. At negative pi, it's a minimum, so I'm down here. I see that the period is 4 pi, so if I go over 1, 2, 3, 4, I'm at the bottom again. And then we utilize the symmetry. If I go 1, 2 over, I'm at the top. In between the top and the bottom is the middle. In between the top and the bottom is the middle. So I get a graph again that should look something like this. Okay, so that was number 6. That's how you graph a cosine. The only thing is you're only looking at what? The x values instead. This is why how we do cosine. Other than that, there's not much to it, and I wish you the best. I hope you enjoyed this video. I try to make it as fast as possible, and good luck to you. Thank you for watching.